Welcome to the first Testing Awards ceremony, brought to you live from the David Intercontinental in Tel Aviv. It is a great honor to have you all with us. The nominees for the best testing tool for Node.js are Mocha, Love Actually; Jest, The Social Network; NodeTest, Home Alone; BDD Speed; Playwright, Inception.
Winner is... Actually, no. We are not going to do a winner. We are just going to go through the frameworks and talk about the differences and commonalities in some cases between them. So my name is Barak. This is me 2 years ago in NodeTLV talking about package managers. This is me last year in NodeTLV talking about monorepos. And this is me this year talking about testing framework. And I think I covered the whole trilogy of your development tools and environment. So I'm dismissed for next year in NodeTLV. It's called Great Expectations, pun intended. So in order to know where we are going, we must know where we have been. So let's go back a bit. This is a short history of how testing evolved over the year. In the 80 years that we have modern software, this is how it evolved a long time. And around the beginning of this century, millennium, just before that, test automation started. And in around 2000, the practice of having agile testing started. And of course, it was not that popular at first day, but then it evolved. And what does it mean to have agile testing? So it means that you write a function, probably a bit more complex than this one, and then you write another function on top of it that is testing the result of the first function. And the first time that I heard it, it sounds like a recursion without a not unclear end condition, but apparently it works, and it works pretty well. But we are developers, and this code is way too verbose, too long, and with a lot of boilerplate. So what do we do when we encounter that? We write a framework that will reduce the boilerplate. So here at the bottom, we can see some way that you could use a testing framework, and you could write a much more concise code that will test the code. And specifically, when we talk about the JavaScript world, in 1995, JavaScript has started, and it was not until 2008, which, by the way, goes well with the practice that we just talked about. The presumably initial testing framework was for JavaScript. It was QUnit. It was aimed for the browser, for the reason that in 2008, JavaScript was still a browser tool. In 2009, Colin has covered that. We start having Node.js with all the involvement. In 2010, Jasmine, another popular testing framework, again, mostly for the browser, evolved and kind of set the standard. And then the golden years, I would say, of Node.js were around 2011. And 3 people were very active in the community. They all have something in common. I cannot pronounce their last names. But other than that, they also built testing frameworks. So Isaac, the creator of NPM, has built NodeTap. TJ, he's the creator of Express and other things. He created Mocha. And Sindre, who has over 1,000 open source packages that he published, and probably every Node developer knows him, he created Ava. Who here uses Ava? NodeTap. Mocha.js. Okay, so the graph doesn't lie. This is pretty much what we saw. Mocha was much popular than the other two, so I will focus on it. And then we move forward, and in 2015-16, Facebook, Meta today, open sourced their internal testing framework, which was called Jest. And Jest became very, very popular. One thing that it did different from, especially from Mocha, is Mocha was focusing on test running, okay, or test harness, sometimes it's called. This was its main thing. When it came to additional things like mocking library or assertion library, the idea was, let's have the best of breed, the best tools, so other people can write other packages or libraries that will do mocking and assertion, and you could just pick and choose the best ones. Jest came up with a different idea. We will do everything. We will do the test runner, the mocking, the assertion, everything in one big bundle. Both approaches are valid. They have some advantages and disadvantages. But for some reason, we can see that the Jest approach took over, and around 2019, Jest became very popular. One reason is probably this idea, but also Jest did one more thing. They broke the demarcation between back-end testing library and front-end testing library. And basically, Jest was a full-stack testing library. You still probably write the code separately, but it supports both. And it became very popular. And for a few years, this testing framework arena was a bit stale for about 6 years or so. 1 or 2 years ago, depends how you count, the creator of Vue, Vue, and the other people in the team have released VTest as also as a testing framework. They followed the success of Jest, so VTest API is very much like the one that Jest is using, but it works in some ways a bit differently. 2022, Node.js is 13, so it's celebrating bar mitzvah. And what do you get for a JavaScript engine for their bar mitzvah? You get them a testing library or a testing framework. So in 2022, Node released their internal Node test library. And around the same time, roughly, also Playwright was released. And I know some of you now raise an eyebrow and say, but wait, we're not talking here about browser end-to-end testing. So beside the fact that I'm a Playwright fan, I just want you to know, Playwright started as a browser automation and still is core functionality. But on top of that, about 2 years ago, they built a test runner, which is basically a test runner, very much like the other ones. So it's a cool, especially if you're running integration tests and such, it's really worth checking it. So the first thing we do, we go and install it. And this is not a benchmark, okay? But it's just indicative numbers on my computer with a cache enabled, so you can't really tell, but you can see that we can install hundreds of packages, and here is where Node shines, because you install Node and you get Node test. No packages needed. So let's start diving in. And the first thing, look at the syntax and hook. So this is a sort of a way that you would write a test. You use the term test, and then you get a callback on the test as a parameter. And if you wanted to write multiple languages, you would wrap it with additional levels. Later on, this style, and again, Jasmine has to do with it, the style that is called BDD Style, Warning, this is not BDD style. This is just nice words for it. But this is what became common. We're using the word describe to include multiple tests, and we use the word it, sometimes the word test, in order to define a single test. And also the hooks, again, this is now a sort of commonality. All the frameworks have it. You would do a before if you're using Mocha, you will do before each, after, and so on to run your tests. And sadly, I don't have enough time, but I want to mention one feature that Playwright has. It is called Fixtures. And this is an addition to the before and each that allows you to define things that are going to run before your test or after your test, but in a declarative way. So you could define something like Axios, and it will set up your server and take it down afterwards. And sadly, I'm not going to cover that. So if we look at this comparison table, and again, I have to say here, I put the comparison tables, few things, take them with a grain of salt, because a lot of the time there are a lot of different nuances that actually change the picture. And also, by the time I get out of this door, something will be merged and released, and it is going to be completely wrong. So again, grain of salt on this one. So everyone has the BDD supported, everyone has the hooks, and Playwright has the fixtures. NodeTLV, by the way, has something similar. Okay, let's go and run our test. It's about time. So what do we do in order to load the test? We write a test. We probably write our test. We probably give it some name that ends with a test or a spec, depends what our favorite style. And then we are telling our test runner that we want to run all the tests that finishes with test or spec with JS, TS, whatever. You can do that in a command line, JSON, JavaScript object, but most of them have the same. And now, this is what most test runners do. They go through the files that you defined in your configuration, and then they start executing it. So they import the files that are related to it, and then they go and they execute the describe callback. And then when they get to the actual test, they find the callback of the test, but usually they don't execute it. Instead, they point to it and they say, okay, now I know what I need to execute. And what you get is something like this one. Yes, animation. You will get a tree of the test that you need to run wrapped in there described for each one of these files. And the other thing that you get out of this execution is a graph of the files that are being used in your test files. Okay, so because it traversed and loads everything, it also has a map of all the files that I need to extract. And this is useful because it allows you, if you made a change in one of the files, because of this graph, it will know exactly which test file you need to execute, like the ones that are here. Jest and vtest even go a bit further, and they allow you to run the find related test or vtest related, which means, and this is great, by the way, for a commit hook. So you can say, go through the files that were changed in the commit and run only the tests that are related. I don't want to run everything else. Node test is working differently, by the way, and we are going to have, Sagi is going to have a longer talk, and also Colin talked about it, Node test. But Node test is actually running the test right away. So it is a file, whoops, let's go and execute it, and without building the whole tree first. And that explains the test only, which again will be discussed later. The other framework that is doing something differently is Jest. Jest is actually, before it starts running anything, it doesn't even load the files. It go and statically analyze what are all the inputs and requires. And who's using Jest? Okay, quite few. So you know that when you start running Jest, you're waiting and waiting. This is one of the reasons, and especially if you're using TypeScript, for example, that it needs to compile. Here is why. So again, Mocha is building the tree. VTest is doing the same. Playwright is basically doing the same thing. Immediate in Node.js and static analysis. This is the core functionality of Jest. Okay, so we loaded. We know what we want to run. Let's run the test, okay? So we run the test. Each file, one by one. What is the problem with that? It is slow. So we want to make it faster. How do we make it faster? So it's usually, and here among the testing framework, by the way, there's some confusion in the naming, but normally it is called parallel. It has, in Mocha, in Playwright, most testing framework will look into your number of CPUs and will run parallel -1. They will run processes -1. Some do it on processes like nodejs, some do it on workers like Playwright and Jest. And to be honest, it's not really clear what is the difference. So this is how the parallel work. Okay, you put it, you give it to a process or a worker, and it just will go and run one by one each file. Usually the separation is by file, and of course it is much faster. Another optimization that Jest and VTest are doing is actually sorting out the test in a way that will optimize it. So what we have here is, if we try and run this test in a very naive way, just run whatever test that you see first, this will take 5, okay? If we have some information, like in our cache, about what tests take longer than others, then we can do something to optimize it, like the one here. So I will start with a slower test that I know, and then run descendantly according to the speed. And here, the same number of tests, I've optimized it to 3. Okay, so this is running in parallel. Running in parallel is very useful when you have a strong machine with multiple cores and you can right away run them. But if you want to run your test on CI, and you should, you probably have weaker machines. We have machines of like 2 cores, maybe 4, but usually like 2 cores. And running tests in parallel on the weak machine doesn't really make a lot of sense. So the other approach to make the test faster on the CI is called sharding. And this sharding is basically machines. I cannot pass test per file. I need to say upfront, this test are going to run on that machine, this on that machine, and so on. But then I can split my test across machines and run it. Another optimization is concurrent. And concurrent, unlike parallel, is per file. Okay? So in one file, I can run the test, so they will execute at the same time concurrently. And why this is working? Because Node, because event loop, because we have async code. So whenever one action is being done, like if you have some IO or whatever, we can do other things. If you try the concurrent for synchronous code, you're not going to gain any benefit. Okay, so if you have async, that's another way, and this will be per file. And in a similar way, we can do random and shuffle per file. That the test, because usually when we split them across processes, there is some randomization there. Jest and VTest do that. This is very useful if you want to make sure that your tests don't rely on one on another and you have some bugs that are crawling down the test. So yeah, this is the randomized, same thing, but just going on different. So again, this is the comparison. Mocha, after years and years, introduced parallel, sharding, concurrent, doesn't exist, neither shuffle, and here you can see what the others are doing. Oh, the painful point, TypeScript and ESM. And I mean, this could be like a workshop, not just a topic on a talk. These are basically the things that we have in order to use ESM or TypeScript. The one thing is native ESM. Okay, so this is what introduced in Node 16, 14, 16, I think. So it loads, Node finally understand the import, and Gil will talk more about it. We have an ESM-like or fake ESM or false ESM. And this means that you write ESM-like code, but then you have some transpiler, let's nickname it Babel, that is actually going to change all the imports to required, all the exports to module exports. So you have a pre-step for it. And the third one is TypeScript. For TypeScript, currently, as of today, we have 3 main transpiler compilers. We have Babel that also know to move from TypeScript, which basically just wraps everything which is TypeScript and say, hey, this is JavaScript. And we have the TSC, the TypeScript by Microsoft, the actual TypeScript, the one that does type checking. And we have SWC, the Rust-based compiler, which is a lot faster. And the status here is that Mocha is supporting native ESM. Same goes for Node. Same goes for VTest. The ESM-like is basically TypeScript is like, VTest is bringing TypeScript and ESM, and the Playwright has TypeScript built in. The orange tick marks are because you can use things like tsnode to do the compiling a tsnode. So you can, when you require the file, it will go through a pre-processing step that will load, that will transpile the file to the simple JS syntax. For Jest, the tsnode is actually wrapped with Jest. We support the different flavors, and also you can do the same for the fake ESM. Okay, mocking. There is a lot. I mean, again, this is a huge topic. Most of the things are done the same. I just want to point out a few things that are different. So one of them is the global mocking. This is something that Jest and VTest have, which means you can put next to your node modules mocks, and this is the name that it should be called, -- mocks folder, and any package that you put under it will actually be mocked automatically. You don't need to write anything on your code. This is not recommended. I mean, don't go and just mock everything and then end up testing almost nothing, but instead do that for if there are some libraries that are really interfere and stand in your way. Hoisted side effects has to do with with the ESM loading, that it will hoist some of the things which will start at the beginning with some of the files, and then you cannot really mock it because it was already referring to the real object. So VTest has this hoisted, which means I can do things before the hoisting. You take everything, you hoist, but I do that before, like changing the date is one example. Import actual or require actual is another feature that Jest and VTest have. And if you want to test a whole module, if you want to test a module, but you actually want to mock a single library, a single function from it, you can say, okay, let's bring me the real module, and I will just tell you which functions I want to mock. And if you have large import, this is your solution. But try not to have large imports. This is a better solution. Timers mock. This came from sign-on. And still, if you go to Jest and vtest, this is a way to fake the time when you're running the test. So if you want to have like a fixed test, and and you can actually proceed the cloak. It is pretty good in sign-on because also Jest and vtest are using it. And Node test people are promising me that yes, Eric is saying yes, it's coming. Cool, yeah. So Eric, you will get the tick mark next year. Okay, assertion. Very quickly. So we have two common syntaxes. One is the assert. The other one that Chai introduced both. Why choose? Let's have them both. So we have the assert and we have the expect. I personally find the Jest expect much more readable. Also, Jest introduced like plenty of matches, so you can match everything and anything. They also introduced the snapshot matching, basically, which means I can only I don't need to copy the code, the object that I want. I can actually say take to match snapshot, and then it will save, and every time you run it, it will check against the data that is saved, and when it is false, when it does not match, it will tell you it does not match, and then you will do update, ignore the test, and move on. Don't do it. So Mocha has the assert. Again, this is with Chai. Jest has the expect, the snapshot. vtest also following Jest, they introduced it. Playwright also has it, and Node.js will have everything. The last thing is reporting, and reporting, I want to, most of them have pretty much the same. You have the human readable, you have the machine readable format, and you can also write your own test report. But I want to focus on coverage, okay? Because when we are running tests, we want to check how much our test is covered. And today in JavaScript world, we have like two main ways to do that. One of them is the Istanbul and NYC that are doing the coverage, and the other is the V8, C8, V8 coverage that is built in. So if you're using Istanbul, the first thing you need to do is instrument your code. And instrumenting your code is basically taking your code and adding a lot of lines in the middle that are increasing specific counters. When you do that on V8, you basically need to tell it just collect the coverage, okay? And then V8, when it executes, it will do something similar. Both of them produce a global variable that is called coverage, and there it has everything. There it has all the counters, and then you can get a file with all this coverage. They look pretty much the same. And then from that, you can build your readable report. The important thing here is to understand that you cannot mix the two. They are doing different things. And in fact, I would highly suggest you, there is a great issue in Jest that is explaining the differences because they are not equal. Okay, they're doing similar things, but they are not equal. So if you want, you can go and talk about speed, talk about what exactly is covered, and so on. Jest and vtest have a parameter that can tell, do I want to use V8? Do I want to use Istanbul? for it. Mocha, we usually wrap it with NYC, which does the same thing. Playwright also doesn't have coverage, and it merely supports the V8 coverage, and Node has built in the V8 coverage. Okay, so here we go. Do we actually have a winner after this talk? And the answer is yes. You are all the winner. Take all this innovation, take all the great things that people are writing, and use it to write much better tests. Thank you.